Transient analysis. As an alternative to decline curve analysis, Citrine can connect with Topaze, KAPPA's rate transient analysis module, and access the modeling capabilities of Topaze. Dynamic data, including rate and pressure for a representative well, can be transferred from Citrine to Topaze, where it is modeled thoroughly. The simulated forecast type curve is then brought back to Citrine and applied to other wells through a transformation. This way, physics-based forecast can be used in Citrine in place of traditional decline curve predictions. This video showcases the workflow for leveraging the transient models of Topaze in Citrine's decline analysis. The Citrine project file for this demonstration contains several wells from 4 different reservoirs. A working set has already been created for wells belonging in Field H. Go to Analysis mode, where only one well is displayed in the dashboard at a time. However, multiple decline curve models can be displayed and compared. The default analysis dashboard contains 6 plots, including decline parameter and decline factor versus time plots, in addition to standard decline curve analysis plots. The dashboard can be customized and saved as a template. Field H wells is the well group of interest, and Field H well 25 is the representative well for the group. 2 DCA analyses already exist for this well, but the interest here is to use a physics-based transient model. The well's data will be transferred to Topaze for transient modeling. Before doing so, Topaze should be running in the background. Select Field H well 25 and click on the To Topaze icon. In the Topaze Analysis dialog, define the fluid properties and test parameters and specify the gauges to send to Topaze. In this demonstration, the default fluid properties and test parameters are used. Select gas rate and casing then tubing pressure gauges, and then click OK. Rate, pressure, PVT, and test parameters data are transferred from Citrine to Topaze. Topaze can handle advanced PVT multiphase, including compositional definition. Proceed to extract a diagnostic log-log plot. Under the Time Range section, activate the selection window. Exclude the initial flowback portion of data with time minimum about 1,000 hours. Click OK. The diagnostic log-log plot is created. Click on the Tools button to bring up the Analysis Tools dialog. The well in question is a multi-fractured horizontal well. The derivative signature on the log-log plot does not exhibit wellbore storage nor boundary effects. Select None for wellbore storage, Fractured horizontal for well model, Infinite for boundary model, and Homogeneous for reservoir model. Click OK. Corresponding analysis lines appear on the log-log plot. The half-slope lines indicate linear flow, the unit slope, the SRV flow, and the horizontal line, infinite acting radial flow. Maximize the log-log plot. Select Show Tool Parameters to view the parameter estimates from the positions of the analysis lines. Now adjust the analysis lines to match the data. Observe that the movement of the lines recalculates appropriate parameters. For parameters known in advance, enter their values and exclude them from the calculation by toggling their checkbox off. Close the Tool Parameters window and restore the log plot. Rename the Analysis tab Diagnostic. Create a new analysis. Rename it Analytical. Initialize it from the diagnostics just performed and click OK. This creates a copy of the first analysis. While holding down the Shift key, click on the Analytical button on the left pane. This action transfers the diagnostic results directly to the analytical model. An initial reasonable match is obtained. To further improve the match, click on the Improve button on the left pane. In the Improve dialog, select Fracture, Half-Length, and Permeability as the parameters to regress on. In the table on the right, the range of the selected parameters can be defined to bound the regression. Click on the Run button. The model match is improved. Create a new analysis. Rename it Numerical. Initialize it from the analytical model and click OK. Click on the numerical icon to bring up the numerical model dialog. The SRV-bounded numerical model will be used. Generate the model. Improve the match based on fractured half-length and reservoir permeability as regression parameters. Create a new analysis. Rename it Forecast. Initialize it from the numerical model and click OK. To create a 30-year forecast, click on the Forecast button on the left pane. This brings up the Forecast dialog. Define a constant pressure forecast strategy with 320 psi for 30 years. Click the Generate button to run the forecast. It is possible to perform an even more complex numerical analysis. For example, complex hydraulic fractures, discrete fractures, multi-phase flow, fully numerical model, etc. could be modeled in Topaze, and then a forecast is generated. Once a forecast has been generated, the next step is to transfer it to Citrine and use it directly in decline analysis. Go back to Citrine and click on the button from Topaze. Analysis tabs in Topaze that have a model in them are listed in this dialog. Select the forecast analysis and select a type curve to be retrieved. The full simulated forecast takes the well's history into account, honoring associated production variations. The type curve forecast is calculated as a single-step response. It is free of superposition and hence can be transformed and applied to the other wells. Click OK. This populates Field H Wells 25, the representative well, with subnodes corresponding to the simulated forecast and the type curve forecast. All the plots now show the type curve alongside the two DCA curves. The next step is to apply type curve from the representative well to the other wells in the group. Click on the N-well icon. In the resulting multi-well analysis dialog, select the forecast type curve and check that all other wells are selected as the target. Set the regression weight to cumulative. Click OK to apply settings. The type curve has now been applied to the other wells in the group. Toggle between the wells to see the match for each well. The match for each well can be improved manually if needed. To see transient models for all wells in one view, switch to the Data mode and activate a dashboard. Select all wells by clicking on the Select All button. Set the plots to Auto Scale Data and Model. All the models are shown for all wells together. Go back to Analysis mode. To see a summary of the analysis results, click on the Results Summary icon. The results can be exported to economic packages, including Aries, Mosaic, or to Excel. In this demonstration, we export the results in an Aries-compatible format. This concludes this video on transient analysis in Citrine. To learn more, please visit our website. For more information, contact support@kappaeng.com or your local KAPPA office.